Good evening. I'm meteorologist Connor Murray here to discuss El Nino and La Nina circulation patterns. Both El Nino and La Nina are opposite circulation patterns that play a huge role in the climate system in some countries around the globe. El Nino usually brings warm ocean temperatures in the equatorial Pacific for at least 5 months. As a regularly occurring climatic feature of our planet, El Nino occurs every 2 to 5 years and lasts for several months and maybe even a few years. La Nina, on the other hand, usually incorporates cold ocean temperatures in the equatorial Pacific. It typically lasts 9 to 12 months. As shown in the picture, during the El Nino years, there is lots of warm water and heavy rainfall off the coast of South America. In addition, there is lots of drought in the Indian Ocean. On the contrary, in the La Nina years, the water off the coast of South America is cool and there is a lot less rainfall. Also, in the Indian Ocean, there is lots of heavy rain and warmer conditions. An El Nino occurs when the trade winds relax in the central and western Pacific, leading to a depression of thermocline in the eastern Pacific and an elevation of thermocline in the western Pacific. The easterly trade winds become weaker and can even reverse direction. The warm Pacific Ocean becomes nearly stationary and can sometimes push eastward and gain heat. As shown in the diagram, during the La Nina years there is a strong upwelling of water off the west coast of South America, pushing trade winds in the thermocline to the east, resulting in warm surface water and rain in the areas around the Indian Ocean. And this also brings cold and dry conditions off the South American coast. As shown in this diagram, during the El Nino years, the trade winds reverse and the cold upwelling stops. This brings weaker trade winds to the west, pushing the thermocline along with it. This brings warm water and wet weather to South America and drought and cold conditions around the Indian Ocean. During the El Nino years, there is less upwelling of the surface, which makes the surface water warmer and more rich in nutrients as the thermocline water rises to the euphotic zone. The result in the rise in sea surface temperature and drastic decline in primary productivity affects the higher trophic levels in the food chain, including commercial fisheries in this region. Rainfall also follows with the warm eastern water, bringing flooding in Peru and drought in Indonesia and Australia. The eastward displacement of the atmospheric heat source overlaying the warmest water results in large changes in the global atmospheric circulation. This in turn forces changes in extreme weather patterns in regions far removed from the tropical Pacific. La Nina's effects are not as severe. There's still drought in East Africa, and farther north La Nina cools the Canadian water cycles. La Nina usually brings drier than normal conditions in the southwest United States in the late summer through the winter. It also brings drier than normal conditions in the Central Plains in the fall and in the southeast in the winter. In contrast, the Pacific Northwest is a lot warmer and has a lot more rainfall in a well-established La Nina year. Additionally, La Nina winters are warmer than normal in the southeast and colder than normal in the northwest. As you can see in this diagram, El Nino causes lots of drastic changes to the climate patterns around the world. In the Indian Ocean, there is a lot of drought, while in the west, on the west coast of South America, there's tons of precipitation and warm weather. This image here gives you an idea of the extreme weather changes caused by El Nino. This image outlines a tropical depression, tropical storm, and categories 1 through 5 hurricanes in their usual paths around the country. In El Nino years, these paths will be changed and might affect other areas around the country. This image on the far left shows you the South Indian Ocean current, and in the middle it shows you the Southern Pacific Ocean current. Both of these currents would be changed or altered in the El Nino and La Nina years. This clip here shows the phytoplankton on the coastline of a continent. During the El Nino years, phytoplankton is much more predominant as there is warm water and heavy rainfall to support their population. The La Nina year, the opposite happens, as the cold water cannot support all the phytoplankton. As for the future of El Nino and La Nina, scientists have developed many models to predict the occurrences of these oscillation patterns. Using these predictions, people can now accurately project when and where El Nino or La Nina may occur in the future. With these predictions, we can accurately prepare for the future and hopefully reduce some of the traumatic events that may follow.
Well, as you can see, there's been a steady rise this century. Government scientists say it's mainly due to our greenhouse gases. Here's the peak of the temperature trend. And even this year's little projected dip caused by the cooling La Nina current will still see temperatures well above the average for the past 100 years.
The bigger question still remains as to the types of changes that may result from an overall climate shift as compared to the El Nino and La Nina changes on a smaller scale. An entire climate change would affect the whole world as opposed to just a few regions across the country. It would also be permanent as opposed to once or twice a decade. El Nino and La Nina have been shown to wreak havoc on many ecosystems across the world, and one can only wonder what type of changes may occur on a larger scale.